In this particular example, we've been given the function h of x. This particular function is an irrational function. There's no way to simplify this function such that we could use the power rule. Instead, we are forced to use the quotient rule. When you look at this function h of x, it has the expression, the square root of x in the numerator, which one can refer to as f of x, and the expression 1 minus x squared in the denominator, and you could refer to this as g of x. So when one uses the quotient rule, we must take g of x multiplied by f prime of x, subtract from that f of x times g prime of x, and divide it all by g of x squared. That is what we've done in the first step of our solution. We have g of x, which is the 1 minus x squared. That will be multiplied by f prime of x, which is denoted as d dx of x to the 1/2. This indicates that we will be taking the derivative of x to the 1/2. I just haven't done it at this particular step. From that, we subtract f of x times g prime of x. Well, the f of x is the x to the 1/2. The g prime of x is the d dx of 1 minus x squared. Again, the d dx indicates that I will be taking the derivative of 1 minus x squared. I just haven't done it at this step. And then that is all divided by g of x squared. Well, since g of x is 1 minus x squared, you can see that in the denominator I would have a 1 minus x squared all being squared. In the next line of our solution, what we've done is we've actually taken the derivative of the x to the 1/2, which gave us a 1/2 times x to the negative 1/2, and we took the derivative of the 1 minus x squared, giving us a negative 2x. Some students choose to do this as their very first step, and you're more than welcome to do so. In some cases, professors will be satisfied if you leave the solution in its present form. They don't mind having the derivative h prime of x expressed as 1 minus x squared times 1/2 x to the negative 1/2 subtract x to the 1/2 times negative 2x all over 1 minus x squared squared. However, some professors will ask that you expand the various terms and combine like terms, and that is what has occurred in the final two steps of this solution. So we have the derivative h prime of x is equal to 1/2 times x to the negative 1/2 plus 3 over 2 x to the 3 over 2, all divided by 1 minus x squared, all in brackets squared.